Hi, Chem Peeps. We're continuing our final exam review for first year chemistry. I'm going to talk about VSEPR theory or Lewis dot structures. And I do have quite a few on my final exam where the kids are going to have to draw out the Lewis dot structures to figure out the answer to the questions. So I hope this helps you. Over on the left, I have for my PowerPoint, and I wasn't able to fix it because it was an image and it wasn't text, but I have the 5 shapes that we deal with. So linear is this one here, and it forms 180 degrees between the bonds. Trigonoplanar is this one. It forms 120 degrees between the bonds, and notice that it's flat. That's why it has that name planar. The tetrahedral is this one right here, and this got moved to the other line, and I apologize that, but it's 4-dimensional. It's tetrahedral because there's 4 bonds, tetra meaning 4, but there's a 109.5 degree angle between there. Students often get, when they draw it 2-dimensionally, they want to say there's 90 degrees, and it's not 90 degrees. Bent is 105 degrees between the bonds because we don't see it in this structure here, but we always have like unshared pairs of electrons up here. And same thing with trigonopyramidal, 107 degrees. It is not flat like the planar one because there are 2 unshared electrons above there. These 2, and I put them last, I wanted to say this, they're always a polar molecule. And that is because of those unshared pairs of electrons that push the bonds down. Okay, so that is a good review of the different molecules and their angle. Now, let's look at the questions. 58 says, which of the following is not a polar molecule? You're going to have to draw them. When we're talking a molecule polarity versus a bond polarity, very different things. With a molecule polarity, let me just finish writing this. With molecule polarity, you must look at the whole structure. That means you're going to have to draw it. Oops, structure. Yeah. Structure. And with bond polarity, we're looking at the sharing of the electrons and whether they're equal or not. So we're just looking at 2 atoms and how they're sharing. Okay, so we're talking about not bond polarity. That'll be a different video. We're talking about molecule polarity. So we're going to have to draw these. So the first one to draw is the ammonia. I always tell my students to think like there's an imaginary box around the element and that you're going to put electrons around those 4 sides until you have 2 per side, which 8 would be the max that you would have. So for nitrogen, this is what it would look like. And then we're going to bond hydrogen. I don't know if I can squeeze that in there. Hydrogen on the bonding sites, which are the single electrons. So we have 3 bonds and then an unshared pair of electrons. This one is the trigonopyramidal, so this is going to be polar. The next one, carbon dioxide. Carbon has 4 electrons, and I'm going to just go ahead and move them up because it needs 4 other electrons to get a full octet. And so this one actually forms double bonds. It is linear and it is nonpolar. All right. The next one, we have water. That was a giveaway for the students. I don't know how many times I draw water in the classroom. They should be able to draw that without thinking. This one is the bent shape. It is always going to be polar. And the last one, hydrogen chloride. Hydrogen has 1 valence, chlorine has 7. And I'm going to put the single bonding site here. They form a bond, not equal structure. And so this is going to be a polar molecule. So the only non-polar one is going to be A. Okay, looking at the next question. It says, what is the VSEPR shape of ammonia? Well, we already drew it. That was probably intentional on my part. And so the student can just look back to what we drew here. And it is going to be the trigonopyramidal. 60. Which of the following forms a nonpolar molecule? So again, we're going to have to draw them. This is going to be time consuming for the student if they're not familiar with the molecules from practice. So the first one is going to be hydrogen, and it has a single bond. It's going to be linear, and it is going to be nonpolar. All right. Next one is hydrogen chloride, which we already drew, probably intentional on my part. This is going to be a polar molecule and linear. The next one is a carbon with 4 bonds, so it's going to have 2 hydrogens, and then it's going to have 2 chlorines. And I'm just going to squeeze that chlorine in there like that. And this one's tetrahedral. Is not equal all the way around the center of this molecule. We have 2 chlorines pulling and 2 hydrogens, so this is going to be a polar molecule. And then finally, the sulfur hydride here, we're going to have, it's very similar to water. It's going to be bent, and because it's bent, it's going to be polar. So our answer here is A. All right. Looking at the next question, it says, which of the following form a trigonal-planar Lewis structure? So we've got to draw these. Now, trigonal-planar has 3 bonds, no extra pairs of electrons, and we're going to find that family 13 as the center atom is going to form that very commonly. So aluminum is in family 13. It has 3 valence electrons, and it has 3 chlorines on it, so I'm just going to quickly draw them on here. Yes, chlorine would have unshared electrons around it, but this is trigonal planar. So let's look at the next one. We have phosphorus. Phosphorus has 5 valence electrons, and it's bonding 3 times the chlorine. And this one does have 3 bonds, but this is the pyramidal one because we have this extra pair of electrons. And then boron is in family 13 also, and it forms 3 bonds, no extra valence electrons around the boron. So this one is going to be planar too. So look at answer D. Yeah, don't be too quick. It's both A and C in this case. Okay, the Lewis substructure of nitrogen would have how many bonds? Remember, our goal is when we're bonding to get up to 8, an octet. And so nitrogen has 5 valence electrons, and we have another nitrogen with 5 valence electrons. They each need 3 more electrons to get an octet if they start with 5. So there's 1, and I'm going to move this one and this one down and form a second bond, and I'm going to move this one in and this one and form a triple bond. And so the answer to this question is going to be a triple bond C. The Lewis substructure for water will have what VSEPR shape? This is a give me for my students. If they don't know this, but if they have to draw it, here it is. It's going to be bent. And I could ask about angles, but I think I remember telling my students over the years I wasn't going to ask about angles for the shapes. So I could have asked something as far as like water forms what angle between bonds, and it would be around 105 degrees. And so that would be a harder question, but well within the fairness of what I've taught. Okay, the last one, how many single bonds would be in this molecule? So carbon's in the center with 4 bonding sites. It bonds to 2 hydrogens, and it bonds to 2 chlorines. And so it is going to have 4 single bonds, C. Okay, so I hope this helps you review your VSEPR theory and the different molecules. Give me a like, give me a share, or save this video. Go back and check my other ones. Leave me a comment. Let me know if this helps or if you need more information, and I will see you in the next video.